I want to go over with you guys a quick way to factor the types of problems that are going to show up in this chapter. It's not going to do all the crazy steps that we did back in October, but it also only works for problems when the x squared term is just a 1 in front of it. It's a nice shortcut. But before I even launch into this nice shortcut, I want to point out what we mean by factored form and what we mean when we say something like this factored form is equivalent to this standard form. We're going to get stuff in this form, and the goal is to change it to factored form. Now, factored form is called factored form because its factors mean we're just multiplying things together. And with these parentheses, we can see the idea is that this set of things is being multiplied by this. These multiplied together make this, and that's why these are two different ways of saying the same thing. Factored form, standard form. I can show that they're equivalent if I had to by taking this form and multiplying everything out. If I take x times x and x times 4, if I then move on and take negative 3 times x and negative 3 times 4, and I combine these like terms, I can see that this does multiply out to make x squared plus x minus 12, and the factored form of x squared plus x minus 12 is equal to this. But there's something else I want you to notice that'll make our jobs today and over the next test easier. Anytime this lead coefficient for x squared equals 1, meaning like I don't have a 2x squared or a 3x squared, I just have an x squared. Something always happens to work out the same way. And this is what it is. Whatever you have first in the factors make x squared, these last numbers always multiply to make this last number, and they always add to make this middle number. It's going to be the case that these multiply to make that, and they're going to add to make the middle. It doesn't work when this is a 2, but it works if it's just an x squared, and that's all we're going to see. So let me show you how to use that idea moving forward. If I had to factor this quadratic, I know it's a factored form, so I know I've got to put parentheses and parentheses. I know it's just x squared, so I know it's got to be x here and x here. Now I just need to think about numbers that multiply to make 10, but add to make negative 7. So I'm going to write all the things I can think of that make 10. I can also do this in my head, if you can do it. These are all the things that might multiply to make 10. And these guys, if they were both negative, would multiply to make 10, and they would add to make negative 7. So I can put them here in any order. Now, if you're not convinced that what I just wrote down here is a factored form of the original expression, you can always take the time to do something you know how to do really well since freshman year, and that is you could take the time to multiply this out. When we multiply sets of parentheses together, everything in the first set of parentheses gets multiplied by everything in the second set. So this makes x squared. That makes negative 5x. We did that. We took care of the x. We'll move on to the negative 2. That makes negative 2x. That makes positive 10. We have these like terms, x squared minus 7x plus 10. We can see that this factored form is in fact equivalent to the original expression. And we can see the pattern of these last numbers multiplying to make the 10 and adding to make negative 7x works out. It's much simpler when the lead term on this x squared term is 1. So I'm going to do it again. If it's just a simple x squared, I know it's got to be x and x. If I can think of things that multiply to make negative 6 and combine to make positive 5, I'm in business. So if I multiply to make negative 6, one of these numbers has to be positive and one of these has to be negative. It's kind of a weird combination because your first thought might be like, let me use these because these will make 5. The problem here is to get these to make 5, I've got to have them have the same sign. But if they have the same sign, they're not going to add to make negative 6. So I can't use positive 2 and positive 2 because positive 2 times positive 2 and positive 3 is not going to work. Even though this makes 5, these don't multiply to make negative 6. Right? So this is not going to be good. But this I can work with. If I make this 6 positive and this 1 negative, now these do multiply to make negative 6. And they do add to make positive 5. So that's how I'm going to write this down. It doesn't matter which order you put these in. You can do x minus 1, x plus 6. You can put the positive 6 here and the negative 1 here. That doesn't matter. What does matter is that it's got to be a positive 6 and a negative 1. And just to verify that it worked, x times x would give me x squared. X times this 6 would give me a positive 6x. I did take x times this whole set of parentheses. I'll move on. Negative x, negative 6. And then I'll look at these like terms and combine them. X squared plus a 5x minus a 6. The numbers I chose multiplied to make negative 6 and I added to make positive 5. The last one, maybe pause the video before I launch into my explanation. If you've paused but you're stuck, start by drawing a template and know that since it's just a simple x squared here, it's going to be x and x. And then you want to think about things that multiply to make one of these numbers and add to make the other. Do you remember which is which? So by now, if you haven't got an answer to check, I'll just walk you through it. We need things that multiply to make a positive 16 and add to make a positive 10. So I'm going to write down all the pairs I can think of that could make 16. It's a positive 16, so they'll have the same sign. And then when I combine them, they have to make a positive 10. So that would mean that this pair would be my best bet. Positive 2, positive 8, or you can put the 8 here and the 2 here. It doesn't make a difference. And this is my factored form. It's factored. If I had any doubts, I can take x times everything over here. I could take 2 times everything over here. This was x times x times 8, 2 times x, 2 times 8, combine like terms, and we got the original problem back again. So we factored, this is the factored form of the original quadratic, and I found numbers that multiplied to make the last number, but added to make the middle number. That's a long video.